There's horses for courses, as my dad would say when I was growing up. We don't think that there's going to be any one silver bullet that solves all the spectrum of needs. You've got longer weeks, even seasonal storage. Just like the power industry has the whole sweep of base load, intermediate, peaking, there's going to be a different mix of battery storages that make up the whole spectrum here.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about long-duration energy storage, providing a sink and a solution for our wide-ranging energy needs. We've been discussing this issue more often. More renewable energy means more energy when it might not be ideal. That means too little solar in the evenings, and maybe too much wind in the middle of the day. This leads to a lot of wasted renewable energy in the form of curtailments. One of my panelists cites a statistic out of California that is almost too high to fathom. We need storage that can last several hours and store several hours of excess capacity. While there's no accepted definition for long-duration energy storage, most sources seem to believe 10 hours is the minimum. Most battery storage sites using lithium-ion batteries are good for about 2 to 4 hours. Some of my guests on this panel don't hold back on their feelings about lithium's dominance in the market. That's fine. That's their opinion. Personally, I figure no energy source should be immune from criticism. But my guests agree that storage technologies take many forms, and one solution is never a silver bullet. Not even lithium. So whether you're talking about a 6-hour battery or a 6-day solution, these durable durations are required for all kinds of needs. My guests today are Eric Steinley from Rye Development, Hugh McDermott from ESS, and Doug Hausman from Burns & McDonnell. They joined me in Dallas for a panel on options for long-duration energy storage at the PowerGen International show last May. This was one of my favorite panels, primarily because there was so much interaction between my guests. You could also sense that these guys had a lot of respect for the work they've done in the field. There was also a fair amount of smack talk, not with each other, which I didn't mind at all. These panels aren't school. They're supposed to be fun, right? We referenced some of their slides, which I've linked to the landing page on the show notes for this episode. I hope you enjoy my conversation on long-duration energy storage. All right, how's everybody doing today? Jay Downhauer, EnergyCast podcast, now in its 6th year. And when it comes to energy storage, boy, I love energy storage. I would say probably a third of my episodes are about energy storage, which is a little bit disproportional, but it's just so important. And again, something that I don't think we talk about enough. I think it's more important than renewables, honestly. And one of the things that I call energy storage on the podcast is the energy industry within the energy industry. Going back to this idea that some energy sectors are loved a little bit more than others, when it comes to long duration energy storage, I feel like that doesn't get near the attention it deserves. It's all about lithium, right? All that short duration, 4-hour stuff. So that's really what we wanted to get into today is what is long duration? Because I think there's kind of an ambiguous definition there about exactly what the dividing line is that makes something long duration and what's the opportunities here. Talking to some of our panelists before we started today, it became very apparent that we are thinking very small about what long duration could mean. It might not just be a couple of hours or maybe a day or two. We're talking about possibly seasonal long duration energy storage, which is really exciting and something that I think a lot of us probably never even considered. So we're going to get into all of it. So our panelists, what we'll do is they'll go for 5 minutes. They'll do a quick presentation, set up what they're all about, and then we'll get into what I like to consider the right brain parts of the conversation. So Eric Steinley, VP of Project Development for Rye Development. Let's give him a round of applause. Thank you.
Thank you, Jay. So I'll try not to put folks to sleep here as we talk about hydropower first, maybe the least new technology out there. I want to talk first off why we're pursuing pump storage hydropower in this particular location in the US and how that kind of fits, we think, around a long-term trend around long-duration energy storage as utilities grapple with making changes as we move forward over the next couple of decades. So the company I work for is a company called Rye Development, and we are specifically just doing hydro development across the U.S. In addition to pump storage in the Pacific Northwest, we have summer peaking conventional hydro in the Southeast, as well as new base load hydropower in the Mid-Atlantic. We're really focused on providing a 24/7 renewable to a lot of non-traditional buyers in the eastern portion of the United States, and then focused on an emerging capacity market, which I'm sure we'll talk about a lot on the West Coast. I think everyone here knows a little bit about pump storage, and if you don't, you certainly know what hydropower is. Our projects in particular are what are called closed loop. These are sealed, lined reservoirs, and our water source is not a lake or pond. We're essentially turning on a tap from a municipal source. After the one-time fill of that source, we're really only using water to make up for evaporation, and we avoid the typical things that a lot of people associate with hydro, with the environmental concerns and a long, long list of permitting hurdles. Right now, we have two projects that we're pursuing in the Pacific Northwest. 400 megawatt project is fully permitted that will begin construction on the Oregon, California. It's slated to begin construction just in 2023. And then a much larger project on the Washington-Oregon border, a 1,200 megawatt project that's about a year away from finishing its permitting process. All of these projects are predicated on an emerging capacity deficit in the Pacific Northwest that's driven entirely out of new policy mandates that started in California and have moved north. By 2019, 2020, the whole West Coast was aligned in 100% clean mandates, and all the various utilities are focused in their integrated resource planning processes on how they're going to deal with that. The demand around long duration energy storage and our interest in pump storage really comes from these utilities starting to study what the policy would look like in their individual service areas around capacity as they add massive amounts of wind and solar into their system to meet these energy requirements. And what these individual utilities found was that from a capacity standpoint, if we can't build new gas, which in large portions of the West now we can't due to policies, then when it comes to storage, anything that is less than 6 hours, with some exceptions, has a pretty low capacity value to these utilities. And so our two projects are 9 hours and 12 hours of storage, respectively. I appreciate being on the panel. I look forward to the discussion today. Thank you.
All right. Thank you so much, Eric. And our next panelist is Hugh McDermott. And before I introduce Hugh properly, I just got to tell a story here. So you may have seen in the program that we were going to have a compressed air guest. They couldn't make it. And so over the weekend, we kind of scrambled a little bit. And we thought, two panelists is great and all, but let's see if we can maybe fill that third spot. Well, we wanted to reach out and see if someone maybe from ESS was available. And luckily, you had a few people attending the conference. So Mr. McDermott's not even on the program speaking in another capacity. He was just walking the floor. And thank God we were able to pull him up on stage, shanghaied into service. Give him a round of applause. That is huge. That is really great.
Hope I live up to the billing.
Thank you so much.
Welcome.
This guy's my hero. Not all heroes wear capes.
So thank you for that, Jay. Good to be here this morning. I wouldn't have missed it even if I was the speaker. ESS, Energy Storage Systems, Inc. Don't ask me how we pulled off that brilliant marketing coup and actually got the name trademark. We did it years ago. It was kind of an unintentional thing, but Google ESS. We started the company a little over a decade ago. We're based in Oregon. We moved into manufacturing facilities in 2017. I was somewhere around employee 35 at that point. We're about 250 plus, on track to be about 400 before the end of this year. Last year, if you were following this space, you would have seen that we went public. Pretty cool experience. And what that did for us basically is put us into the time machine, I call it. Put a lot of money on our balance sheet that we could really focus on accelerating our manufacturing scale up. Iron flow battery technology is what we do. The electrolyte is iron saturated in salt water. That's it. Nothing magical about it. We give out the recipe. We might not give you the fine percentages, but it's a straightforward, easy to source materials, no exotic materials, no conflict diamonds. We don't have to get anything from any hard to get places. The way it works real simply is we have a sandwich construction, if you will, battery module. Each layer's got carbon, graphite, monopolar and bipolar plates, and you've got a membrane between them. And during the charge cycle, the iron is coming out of the solution and just sticking to the negative electrode. So we're just building up a thickness of pure iron. It's food grade iron, in fact. And during discharge cycle, we're not reversing flows or changing the pumps in a different direction. All we're doing is reversing polarity, and now the iron wants to dissolve all back into the solution. And what we solved, because we didn't come up with that process, what we solved was how to make that process basically inert. We can repeat that thousands and thousands of times with no corrosion, no breakdown, no loss of material. And we did so jointly with the U.S. Department of Energy through their ARPA-E program. It's a multi-year program. We're one of the first to actually kind of graduate from a peer review idea to full commercialization. The modules that we're making today, it's a second generation design. We went through several prototype designs and sort of a first gen commercial scale. To give you a sense of the dimensions, it's about a meter cubed, weighs about 600, 700 pounds, and has a capacity of up to 12 hours of storage. And when I say capacity, think of gap space that we can put iron plating in there and still maintain the proper flow rates. Can we go wider? Yes, we can. We have that in our roadmap to get out to longer durations in the future. A couple of the things that are kind of cool about it, it doesn't require any fire suppression. It's a fire stopper, not a fire starter. 5,000 gallons of water in it. It doesn't require air conditioning. Last year, we had a record-setting heat wave in the west, south of Portland, where we're based. We had 3 consecutive days were above 115 degrees. We had the container doors open. You can see nothing going on there. The actual battery loves the heat. In fact, the internal operating temperature of these year-round is around 100 degrees. So we actually insulate these containers to keep the heat in, putting it out in places where solar tends to want to go. You don't need any air conditioning for these. Conversely, you can put these into winterized locations, and we can talk about different ways we do that. But basically, this is primarily a behind-the-meter product for C&I type customers or utilities that are doing DERMS type projects or maybe temporary type projects, because these are probably one of the few, if only, batteries that you can put out in the field, run them for years. They don't degrade from the cycling, and then you can decommission them, take the liquid off board, redeploy them somewhere else, or recommission them as a brand new battery. They've got a design life of 25 years. What wears out? It's pumps and motor drives primarily. The rest of it's PVC plumbing. Everything else is off the shelf. We call it the Home Depot. If we're running short on parts, we can literally go down and get some of the parts. What we're doing for the front of the meter and utility scale is basically taking the same technology. We're currently in the design process to launch our first pilot project in Q1 of next year. This will be with Portland General Electric, basically packaging the same battery modules into a skid. Picture a skid that's the size of the shipping container, but nothing but power modules in there. And you've got a 300 kW skid that now I can put a tank of any size up to 12 hours. A few years down the road, if I wanted to expand the energy capacity, all I'm doing is adding liquid. And the liquid is perhaps our secret sauce or our superpower here, because it's just iron saturated in water. So hard to imagine that any dollar per kW addition of capacity can get any cheaper than iron saturated in salt water. Some of the things that make iron flow battery a little bit different from most batteries, it's that unlimited cycling capability. All the aspects in this battery are designed to last for decades. You could do a light refurbishment. Unlike lithium ion batteries, the more you use this battery, the lower the cost per unit is, because you're not having any degradation cost. You're not having any augmentation. So it's just the opposite. You want to use this. This is intended to be a workhorse battery. It can do every function that any other battery can do. We think that's pretty cool. You wouldn't buy it for ancillary services only, but if you had one, there's no reason why you couldn't do that on top of all the other things you're doing with it. Last, and I'll wind up here, is just that safety and sustainability part. It's 100% recyclable with today's technology. Nothing exotic there. It's 9540A certified, it's UL certified. So Doug was just telling me before we started the session that we might be the only battery out there that's 9540A. All the lithium ion batteries are out there with Chinese certified 9540A. And that's something I learned from the session. So attribute that to the good fate of being here this morning. That's my presentation. Look forward to any questions you may have. Thank you.
Thank you so much, Hugh. And then wrapping this up is Doug Hausman, who probably needs no introduction. I mean, this guy is the hub in the energy storage sector. And we have a mutual friend, Alex Vukajevic, who worked at Duke Energy in their emerging technologies. And then he moved over to Exelon. And I had a conversation early this year where I said, hey, I need a third panelist. Who do I need to get? And he just goes, Doug Hausman. I was like, well, you don't know who the other 2 panelists are. He goes, just get Doug. This is who you want on the panel if you don't have him. So without any further ado, we're going to show you why Doug needs to be up on this panel. Thank you so much, Doug.
How many of you have a lithium-ion battery? Okay, you have a 1 in 3 chance of that battery surviving its lifetime without burning to the ground. You have a 10% chance of actually having the warranty run through to the end of the warranty without violating it. Lithium-ion batteries are probably the worst thing that happened to the industry, period. Long duration storage, as far as I'm concerned, means that you're going to be able to put power away for months, not days, not hours. Battery storage in the U.S. today is 0.3 of a second of the energy we need to use in the United States total. We got a long way to go to put months of power away, and we need a lot more technologies than lithium ion. Thank you very kindly. By the way, that curve that said lithium ion was going to get cheaper and cheaper and cheaper, doesn't work anymore. Lithium ion prices are up 35% as of this morning. I just got another email from one of my suppliers since the beginning of the year. Lithium ion prices bottomed out in September of last year. The price is up 35% since the first of this year. These are our choices. We got lots of choices. There are over 600 ways to store energy. 43 of them are commercial lithium-ion chemistries. The other 550 are something else. Lithium-ion is likely to be one of the most expensive choices in a year or two. Pumped hydro works really well. Iron salt works really well. Neither one of them requires minerals that we can't find in the U.S., so we don't have a big supply chain issue. And frankly, for long duration, when we look at it carefully, the ones that don't have not signs on them are our real choices. I use this set of characteristics to rate storage. I do a red, yellow, green when I go out in public. The spreadsheet actually has real numbers in it. We've got about 230 technologies in the spreadsheet. Lithium ion, of all 43 chemistries, ranks in the lower half of the choices in terms of these characteristics. Thank you.
Oh, boy. Everybody awake? All right. So, all right. I told you. All right, Doug, I'm going to put up these characteristics one more time. Let's take a look at these. So this is almost kind of like the eHarmony of characteristics for energy storage, huh? Give us a little bit of insight here. And then the other two panelists maybe too can add to any other characteristics that they think are important in this lovely little list.
Those characteristics deal with everything from total cost to capital to insurability of the particular system. And believe it or not, that's a big and important part of putting in an energy storage system. Unless you're a great big company that doesn't even do a liability cap for insurance, you do all self-insurance. And even most utilities at somewhere between $10 and $100 million use an insurance policy to cover liabilities above that. We got about a third of the technologies in our spreadsheet that when we talk to FM Global aren't insurable. And if you've never worked with the FM Global spec sheet 55-3, spend a week on the particular technology you're thinking about and fill that in, turn it into FM Global and see what you get. And I'm going to guarantee that some technologies are insurable and some aren't. And that's a big important part of this. The other thing you want to look at is how many cycles, and we look at how many cycles are warranted in the warranty on the battery, not how many the manufacturer says the system will take. We had CATL come in and talk about 12,000 cycles for their lithium iron phosphate batteries. Sounded good. Let's look at the warranty. 3,000 cycles. Okay. There's a little bit of difference there. 3,000 cycles is about 8 years, one cycle a day. Look a little deeper into the warranty. A partial cycle is a cycle. So if you're using this battery to do smoothing or frequency response, you might put 100 cycles a day based on the warranty on that battery. You wonder why most of the lithium-ion batteries in PJM stopped doing fast response after 18 months? That's why. There's no silver bullet. That we've got 35 use cases that we cross with these 12 characteristics in the different chemistries. In doing that, we can typically find 5 or 6 chemistries that work for any particular project. And then it's a question of what's important from a price and insurability and other things point of view.
Anybody else have any other characteristic? Any want to add a 13th or 14th? You guys live by those too, right? You, Eric?
I might just add one that comes up quite a bit for us is land use, right? We're building a hydro type technology, so people automatically think that your scale is going to be massive. A good example, our project in Washington, the only 2 visible components of it are 2 60-acre ponds. And that might seem like a lot, but those 2 60-acre ponds are going to provide 12 hours of on-demand renewable electricity in Washington state. And there's a lot of renewables getting built in that state right now. And so just to give you a comparison, it would take 50,000 acres in Washington state to build that much solar. And it would take almost 10,000 acres in Washington state if you're going to do that with wind. And so land use constraints are especially something that we're hearing more and more about.
So that's why topology is in that set of characteristics.
I just wanted to chime in. Maybe it's implied in there, Doug, but I didn't see warranty in there.
that goes into the number of cycles at the top, and it also goes into the hazards and risks down below in there. So we split the warranty into 3 different pieces that we take a look at when we do this model. Yesterday, in our distribution storage class, we looked at 70 different types of storage against this set of characteristics in a 10.5-hour class. That was a lot of fun.
Yeah, we spent almost 2 years to get our warranty insured. Our warranty is backstopped by Munich RE, and those of you who are familiar with infrastructure, they're AAA rated. They're kind of the gold standard out there. And it's obviously a German company, and so everything from quality, manufacturing, annual audits, but it basically ensures the parts that we make, the technology stack as we call it. And to Doug's point on warranty, I thought was a great lead-in. We provide a 10-year warranty currently. We're looking to extend it out to 2025. We're not there yet, but we'd like to get it aligned with typical project tenures on the solar side in particular. But it's unlimited. You're not going to ever risk voiding the warranty because you did a half cycle today or 5 cycles today or 400 cycles this year in your system. It's an uncapped utilization warranty there. Something that makes flow batteries generally different and unique from other classes of batteries.
Hold that mic. I got a question for you, Hugh. The supply chain. You were talking about warranties there. Yeah, maybe lithium ions might be able to support the warranty and make good on some of the batteries if crap out earlier. But what good is an 18-month lead time, right? What about a supply chain that runs through Asia? Or I think we're hearing some of these critical metals are coming through Russia. ESS, iron flow battery. Sounds to me like we can get iron here in the Western hemisphere. So talk a little bit about that. I mean, you guys can provide the batteries now.
Sure.
Right?
Yeah, that's a great question. About 85% of the part count that goes into our product is all sourced here in the U.S. The things that we don't source in the U.S. are electronic components and inverters. When we do the AC versions of ours, come from Europe. Everything else is domestically sourced for. So we've got that unique distinction, I think, of being made in America and sourced in America. We're not subject to the same pressures on supply chain, but I don't want anyone to think that we were immune in any way from the pandemic's impacts on shipping and every other disruption. We've seen just about the same kinds of things everyone else has, but at least that's one issue that we're not as concerned about is those supply chains from foreign places or places we don't want to be doing business with.
Hugh, are there fewer chips per module? Like every lithium ion needs a chip.
So the chips come into the electronic components. And so you see some delays there. Fortunately, our suppliers came to us early on and said, hey, by the way, we see a shortage. And so we've been strategically stocking on some of those long lead items. So we're not as impacted, but we're constantly trying to build second and third tier suppliers to basically grow our manufacturing capacity. And that's really the number one challenge right now is getting second and third sources and getting the volume up.
Yep.
Yeah, if you're getting something that has minerals like cobalt or manganese or nickel or anything like that as a battery, go to your trading organization and ask them to buy commodity futures for the metals that are involved in that particular battery or storage device so that you ride that commodity price increase and you hedge against the increased cost of your battery. Now, we've got a big problem in the industry right now because the London Commodities Exchange pretty much blew up their credibility a few weeks ago when nickel went from $8,000 a ton to $100,000 a ton in a 2-day time period. And so they just kind of wiped out that second day of trading. It said it never happened. So the credibility is gone, and we're now seeing all of that metal trading move to the Chicago Commodity Exchange. It'll probably take 6 or 8 weeks before that transfer settles out, but we can expect a rocket ride on cobalt and nickel and other things like that so long as Russia is doing some of the things that they're doing.
No doubt. Eric, let's talk a little bit about topography, like we talked about as one of the criteria. And it seems like Rye has been able to do some creative things with pumped hydro where you don't have to have perfect geography, right? And you're able to be a little bit more nimble. And pumped hydro's got some opportunities here, right?
Yeah, definitely. I think there are some topographic constraints for the types of projects that we're looking at. You still need some vertical relief, but thinking that you need somewhere between 500 or 1,000 vertical feet of relief is not necessary for a number of the projects that we're doing to make them work. I mean, to take it a step further, there's companies like QuidNet now, who we're not affiliated with, but a pump storage scheme where you don't need any topographic relief at all. They're using a mechanical type project and existing wells, and this can be scaled incredibly small even. So yeah, there's a lot more opportunity. And again, back to the supply chain side of things, a lot of our time is spent talking with elected officials around policies that are ultimately driving our industry around storage. There's a lot of concern with elected officials on both sides of the aisle, even if they know nothing about the grid or renewables, they understand that vehicle electrification is real and that's going to happen. And so they have concerns about the grid competing for the same types of supplies that vehicle electrification is going to, or the same supply chain. I think for us in this room, as we think about the grid and the changing grid, it behooves us to really try and focus on technologies that don't compete, at least in some instances, with vehicle electrification.
And remember, pump storage can be seawater.
Right.
Doesn't have to be fresh water. Pump storage can be done in a deep mine, can be done in an open pit mine. It can even be done with sand dunes like Ludington was done in Michigan 60 years ago. And Ludington just celebrated its 450th terawatt hour of storage, even though it's only 16 gigawatt hours of storage over 60 years. It's done 450 terawatt hours of total storage. So there's a lot that can be done with pumped hydro, and there are a lot of options, and you don't need a river or a dam. But there are 26,000 dams in the United States that are in series on rivers that are unpowered. They offer 90 gigawatts of storage capability if we decide to take advantage of them. And the structure already exists.
Yeah, that was really exciting, this idea that the lower reservoir can just be the sea. It can just be sea level.
That's Ludington, and Lake Michigan is the lower reservoir.
Right on.
And we kill 1 ton of fish per year at Ludington. Sports fishermen in Lake Michigan take 5 tons of fish a day.
All right, let's hear from you guys. Who wants to talk?
So I think one that's really interesting on my mind, levelized costs of electricity generated by long-term stored energy. How close is that to competing with baseload gas fossil generation? Because that seems like it's a tipping point.
As a consultant, I'm going to say it depends, because it depends on what the electricity cost that you put into storage. Then you got to take the losses to get it into storage. And once it's into storage, you have to take the self-loss from whatever the storage medium is. If you can, and this is true in California, they curtail 1.6 terawatt hours of electricity from solar last year. They're already at a terawatt hour this year. So that electricity has no value. So if I can take zero cost electricity and put it into storage, then given pumped hydro, given ESS, I can put that power back out on the grid for right around $28, $29 a megawatt hour, which competes nicely with gas and other technologies that are out there. And I don't end up curtailing all of that energy. And I can do it with hydrogen right now at about 29 cents a kilowatt hour, converting curtailed energy into green hydrogen.
Once you use up that curtailed energy, then it gets more expensive.
It does, except that right now California is running about 1,000 hours a year at minus $15 a megawatt hour. So that's even cheaper energy. You pay me to put it in storage.
Tell us who you are.
My name is Luke Soy. I actually work for General Electric in gas turbines.
I'm Frank Kalani from Wood, and I guess I was going to suggest another item on your list. What about charge time?
Charge time depends on the technology and how you design things. If I put more step into ESS's battery, their flow battery, then I can probably charge the whole thing in an hour. It means more infrastructure, but if I change the design, I can charge faster.
Right.
I'm working right now on a project for ferry boats. I need to charge the battery in 30 minutes. I need to discharge the battery, fuel the ferry boat in 15 minutes, and I need to move 10 megawatt hours in and out in that 45-minute time period. That means I can't use a standard manufacturer containerized solution. I've got to engineer the charging and discharging side of that storage.
Well, that's what I'm suggesting is a key characteristic, because sometimes you need to charge faster. Perhaps when the curtailed power is available, you need to charge during that time, and you might want to discharge.
Fast charging is one of the use cases we look at that's across to these characteristics, because I can change that. It's not a fundamental characteristic of the storage technology.
I'm Fred Buckingham with Nays Corporation. You just mentioned obliquely production tax credits, so I'm going to ask a question that may get me thrown out. Should there be a policy decision to implement some form of support similar to production tax credit for storage?
So there is proposed legislation for storage tax credit, and there has been for years. If you were coupled on the same circuit behind a solar system, you get the same solar tax credit. The standalone tax credit is what's proposed proposed in D.C. under the Build Back Better legislation. We've been monitoring that very closely. We're also cautiously optimistic that will come through as it has a Made in America additional incentive, which may go above and beyond what we've seen in the past as a ITC. 30% ITC is what the solar industry grew up on. That's in the existing legislation now. They're looking at, depending on certain other conditions, among them being American-made, using American jobs and union labor, and certain communities, you can maybe get that up to 40%. Of course, hopefully that would come through for our customers.
Hector Raymond with Munich Re. We are one of the insurers of battery projects. With supply chain management, we see a lot of EMS and BMS suppliers being involved in the process with certain battery technologies. With that, we can recognize there's some element of risk with those types of systems not being validated per se. What's your best recommendation to mitigate using a thorough validation process between those that are coming out of the smaller project space into utility grid scale?
So I think the first thing is you need to take a careful look at the technology and evaluate the pain points and the risk points in that technology and what can go wrong. Many batteries have fire risk. Many batteries do not have a fire risk. If I've got a first level, 4th edition, 9540A certification down at the cell level, and I don't have a fire issue at that level, I probably don't need to do a lot of validation on fire systems. On the other hand, if I have an organic flow battery and I have a toxic gas potential issue, I need to do a good validation on how I eliminate that toxic gas. Organic flow batteries are very different from what ESS sells, and there isn't a risk with ESS's system. The organic flow batteries have a chemistry that is typically about that long in 14-point type. So you got to take apart each system and look at what all the risks are and figure out what the validation needs to be.
Yeah, a lot of times we see certifications come in at the cell level, at the unit level. Very rarely is it at the system level. And at the system level is when you're validating the full EMS or BMS systems, and very rarely are we seeing that come in as full unit testing.
Right. We'd start with the battery part, and then we look at what gets added to the system, both to mitigate risk and potentially adding risk to that system. So you got to look at validating the inverter, all the protection system, the BMS, the EMS, all of your stop limits, and so on and so forth in the system. Our checklist for commissioning runs about 38 pages of validation checks, some of which start in the factory before anything is ever shipped.
So with that comment, we usually focus and feel more comfortable with those that have been fully integrated systems into that process. So fully agree. Thank you. Appreciate it.
And you guys do nice work. Thank you for participating in the industry.
I love the back and forth here. I had a question here. I want to talk about the toolbox a little bit, and you had a great slide here. And of course, you eliminated a few of them there, Doug, but let's take the Ghostbuster signs off for a second. Okay, so a lot of tools here, right? And
600 plus chemistries and methods for storing energy at this point that are commercially available.
Well, I appreciate you making the slide a little less busy. Hugh, I know that in addition to flow batteries, you guys are all kind of mixing and matching a little bit. So talk a little bit, Hugh and Eric, a little bit about some things maybe that are complementing what you're putting in the field. And then Doug, tell me about some of the surprises. Let's start with Hugh and Eric first.
So I think what you're talking about is ecosystem and how we integrate. So going back to my analogy of we make a box, everything that you need for the battery itself is inside the box, and you can get it AC or DC. What you also need to make a full solution, depending on whether it's a commercial, industrial, or utility, typically is going to be some type of either site controller or back-end integration to a SCADA or some type of utility dispatch platform. We have a standard Modbus interface. We use a SunSpec protocol, so it's straightforward field mapping. Tricky bit tends to be not the actual mapping. That's a very brief task. It's the actual test to see that inverters respond the way they're expected to respond. We can also integrate with third-party inverters. And then typically as you get larger and larger projects, transformers tend to be, and medium voltage switchgear tends to be part of the equation. I'm sure Doug can expand on that much more, but we're agnostic as a product. We sort of stop at the box and trying to make all the interfaces such that we can plug and play with any other party.
Any other storage, any other generation. I think you have a project. You're partnering with lithium as well.
Yeah, there's 600 different storage technologies. I didn't even know there were that many. There's horses for courses, as my dad would say when I was growing up. We don't think that there's going to be any one silver bullet that solves all the spectrum of needs for this century. You've got the seconds, you've got the minute type storage. We're in the more than 6 hours, less than a day kind of spectrum. You've got longer weeks, even seasonal storage. Just like the power industry has the whole sweep of baseload, intermediate, peaking, there's going to be a different mix of battery storages that make up the whole spectrum here. To the extent that technology like ours can be coupled with, say, a lithium-ion system, there's at least one case application where we think that that is interesting, and it's where you would do some optimization around a wind integration, where if you miss a wind forecast by a foot a second, it can be megawatts and may not be long-lived, but you want to have some surge capacity. Flow batteries, you wouldn't want to oversize necessarily because that's a lot of capital costs, but you could put, say, a 5 megawatt bulk energy flow battery and a 1 to 2 megawatt lithium battery, that 1 to 2 megawatts not being used heavily, limiting your cycles in line with what we were talking about earlier, but maybe under certain conditions, a 1 megawatt could look like a 2 or 3 megawatt because of the C rate capabilities that take certain chemistries in lithium. So you could maybe have a 5 megawatt battery for short periods of time look like a 6 or 7 if the conditions justified, if your modeling said that there's a certain number of hours in a year where I'm curtailed and I can actually get paid to charge that battery. Those are the kind of use cases that we're starting to see. The other ones that are also emerging would be in the electric transportation, the charging infrastructure. Some of those have some very fast charge requirements, but lots of energy has to transfer. And so it's a whole new domain, and people, I don't think, have truly figured out where's the right blend of offsetting the distribution level upgrades that are required for particularly electric trucking, which have massive amounts of power needs. So we see some possibilities there where there could be some hybridization on the technologies.
Eric, who are you working with?
Yeah, great question. So our projects are large scale. They're not modular. We're interconnecting into the grid in locations where there's sometimes a dozen different utilities with transmission rights. Our projects are pretty complementary to areas where utilities have existing hydropower. It's a mature technology. They're used to operating it, owning it, and they understand how it works. Some things that were complementary too. I mean, that slide I had earlier that showed how there's legislation up and down the West Coast. A lot of wind and solar has been added in sort of fits and starts over the last 20 years. And so you have California-owned wind projects in northern Washington state. You've got solar projects in Oregon that are with contracts into California and all over the place. So our projects have been able to offer a tolling type arrangement to utilities where we analyze their existing wind or solar projects plus forecasting what they're going to buy and actually integrate into that particular substation or transmission system and offer an all-around better product. But again, it's pretty big scale. Our projects are pretty large in size. Also, things that we've been able to do with our projects are offer a seasonal product. Since we're offering and sort of competing with gas pricing, right, for a capacity product on the West Coast, utilities in California have a different capacity peaking need than the Pacific Northwest. So by interconnecting at the right location, you can split that and beat lithium ion pricing.
Yeah, absolutely. Hey, talk about the flywheel thing. I always thought that was interesting.
You mean sticking a flywheel in front of a battery so that you're not hitting the battery very often?
That's right. That was cool.
Yeah, it works fairly well. We're in the process of putting in a couple of flywheels at Camp Pendleton on the base to do smoothing for a couple of solar projects on the base. And what we do is back those with batteries, and we haven't picked the technology yet, but we probably will here shortly, Hugh, so you know which way I'm leaning. But the idea is the flywheel does the smoothing, and you're using the inertia of an Edison-style flywheel, not one of these fancy-dancy million RPM that if you screw up the magnetic field, you create shrapnel, but good old-fashioned heavyweight 1800s flywheel. You get not enough energy. Some of it goes from the flywheel into the system to fill those sags. You get a swell. You pull that off into the flywheel. As the flywheel gets down to close to the minimum, you hit the battery to speed the flywheel back up. If it gets close to the maximum speed, you push that extra energy back into the battery, so you're hitting the battery maybe once an hour rather than 50, 60 times a minute in some cases on a cloud transient day. So you save the battery. Flywheels aren't that expensive like ESS. You can truck the structure to the site, and then instead of just adding water like ESS does, you add concrete or you add sand or you add some other weight to give yourself the inertia, so you're not trying to truck the whole weight of the energy storage from one place to another, and it's a lot easier to move. Another way to do that is with super caps. We're doing a 5 megawatt by 2-second super cap array to do smoothing.
So a lot of tools there, guys. Who else has questions?
James Peterson, Idaho Power Company. Question for Eric on the pumped hydro storage. Just curious, you mentioned you're a year out on one of your projects from a permitting perspective. And I know it's site specific, but maybe your more optimal projects, what do your clients in your organization view as reasonable permitting duration? Correct?
Yeah, so the company I work for, RYE, we were the first to win some of the early pilots on licensing for Federal Energy Regulatory Commission licensing reform. So we did the 2-year pilot. It was successful and did that with a project in Kentucky. And it wasn't a project in a pipe where there was no issues, right? There was dam safety issues. There were ESA issues, cultural resource issues, you name it. And we've been a big proponent for a while. We were the only group on the industry side pushing for pump storage licensing reform as part of the group called the Uncommon Dialogue. You might have heard about it. The New York Times and journals had a few articles about it. Right now, there is legislation on the Hill that would allow for a lot of the newer pump storage projects to be fully permitted in 3 years, which if you're in the hydro industry, that's a very short period of time in comparison to the timelines we've been up against. The project we have in Washington State is currently pushing an expedited timeline, but it's not quite that expedited.
Thank you.
Todd?
Maybe I get the last one here.
Yeah.
Thank you all for the good conversation. But, I'm a utility executive. I have a zero carbon goal that I have to hit. So in the next 3 to 5 years, which technology is scalable and I should be investing in?
Like Shark Tank.
You can't give me all 600 of them. Focus this a little bit for me.
He's looking at you.
There are probably 2 or 3 that I would look at in terms of scalability and usability. The first one is likely flow batteries, followed immediately by pump storage. But the dark horse that might win the Kentucky Derby may be green hydrogen in the long run. To begin with, we need 120 million tons of hydrogen a year to make our shoes, our clothes, our medicine, our cosmetics, and all the other things that we use hydrogen for today. And that's a billion tons of CO2 we make every year to make that 120 million tons of hydrogen. There are a lot of problems with hydrogen. It's not my betting horse at all right now, but it's an important thing to think about because there's already a market for a large percentage of that, even if nothing changes. And we've gone from 46% round trip efficiency 2 years ago to 72% round trip efficiency with some of the stuff that's just emerging out of the labs. So it's starting to be something where the round trip is actually competing with some of the storage technologies that you look at. Pumped hydro, you're looking in the high 80s. Yes, the system is again in the 80s. Some of the lithium ion is in the 90s. We're not going to get to the high 90s with hydrogen. We're probably going to get at best to an 80, but it will be a competitive technology if we get there.
Well, if your horizon is 3 to 5 years, you better start buying now. That's what I would say. Just with lead times and the shortages in the industry and time to get these projects deployed. For us in particular, it's how fast we can scale manufacturing. That's really the only thing holding us back on the larger projects. It's just we can't scale fast enough.
The only thing I would add is that diversity is good, a mix of technologies. Of course, we're biased on the pump storage side, but I would say that, and I don't mean to pick on California at all. They've led us in a bunch of different ways that are quite positive, our industry, but there is a lot of focus on lithium ion specifically and not a lot of interest in diversity in large portions of the state. And that includes a variety of buyers that are compelled to purchase storage and massive amounts of it in the next couple of years. So maybe leave with that.
All right. Well, there you have it. I think we're at the top of the hour. And thank you so much for everybody who asked all the questions. And thank you so much to our panelists. It's different from what we thought it was going to be 48 hours ago. Sometimes it's better to be lucky than good, I guess, sometimes. That was my panel on long-duration energy storage from the PowerGen International Show last May. 2022 was a bit of a slow year for live episodes, not as many virtual events as we did in the last 2 years. The good news is that I've set up a few panels already for 2023, so stay tuned. A few notes from the panel we just heard. Hugh mentioned an investment tax credit that was part of the Build Back Better legislation. That credit was passed in the Inflation Reduction Act. Congress has not yet moved forward, however, on the 3-year permitting piece Eric had mentioned. I want to thank my guests for their time. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 150, another milestone. Be sure to join us next week when we explore how to store energy with CO2. Until then, I'm Jay Dowenhauer. We'll see you next time.